relationships. This is the last lesson in Module 8, so tomorrow, if you're on track, you'll be taking the Module 8 quiz, and then we'll be starting Module 1. So this lesson goes into a lot. We have, first of all, a lot of vocabulary to understand. Some of this you may know, some of this you may not know. So first, let's talk about congruent angles. Congruent angles, they are angles that have the same measure. So it just means if there's two angles that have, when you measure them, if they have the same measurement, that's how it works. Okay, so they have the same measurement. So next we're going to talk about vertical angles. And vertical angles, I'm just going to say it because it's a long explanation. But vertical angles are the opposite angles formed by two intersecting lines. So vertical angles are congruent because the angles have the same measure. We'll go into some examples here so you'll understand them. Adjacent angles are they are pairs of oops, wrong one. They are pairs of angles that share a vertex and one side but do not overlap. The vertex of an angle is the point where the sides meet. Okay, complementary angles are two angles whose measures sum 90 degrees. Then supplementary angles, they have the same thing, they're the sum of 180. Okay, so let's go into example 1 so you kind of understand what I'm talking about. So in this angle group, or the diagram here, we're going to name a pair of vertical angles. So vertical angles are opposite angles formed by intersecting lines. So if we look here, it looks like, I'm going to try and highlight it, AFB and DFE are vertical angles because they're the same opposites, but just kind of flipped. Okay, so if you look, they're flipped. So how we write that is we go like that, as if we were making, but we kind of want it more upright. And then, so AFB along with DFE. Name a pair of adjacent angles. So remember, adjacent angles share a vertex and a side, but they do not overlap. So let me kind of erase all of that. And if we look here, it looks like AFB and BFD. So this one and this one. Because remember, they both share a vertex, which is right there, but they don't overlap each other. So once again, it's AFB and BFD. Now we're going to name a pair of supplementary angles. So adjacent angles formed by intersecting lines are supplementary. So if we look again, AFB once again, along with BFD. So those two angles once again both fit into the same thing. Because if we look at so once again, AFB along with BFD. Name two pairs of supplementary angles that include DFE. So any angles that forms a line with DFE is a supplementary angle to DFE. So if you look, so DFE is right here. EFA, let me use this one actually. Of course, it erases the wrong one. EFA along with DFB. So EFA and DFB. Then find the measure of AFB. So we'd, I can get that image back, of course. But you'd look, get AFB. So how you would do it is use the facts that AFB and BFD in the diagram are supplementary angles to find AFB. So we would do M, because we want the measure, of AFB, plus, because remember we're going to use supplementary angles to BFD, equals 180. And now we're just going to solve for it. So this angle right here is 50. Hold on, yeah, because we're just going to combine it. So this is 50 plus 90, which gives us 140 equals 180. But remember, we have to have an x. So x plus 140 equals 180. And then we're just going to solve like a normal equation. Minus 140 gives you x equals 40 degrees. Okay. Oops. Let me resolve this. Again, if you ever have any questions, just message me on Canvas and I'll help you. Now, let's find the measure of EHF. So once again, oops, I pressed something on. Okay, so what happened? Okay, it's fine. So actually, first we're going to do A. So we're going to identify supplementary angles. Right? Hold on. Okay, yeah. So first we're going to find supplementary angles. So in this case, it is EHF and FHG, because as you can see here, these are both into it, and one here, one here. Once again, our supplementary angles are EHF and FHG. Oops, I forgot my symbol. Now I'm going to try and find x. So it is, I'm going to write off to the side here. That was a good M. So proud of myself. EHF plus the M of FHG equals 180. And then just because the sum of the measures of supplementary angles is 180 degrees. So we're going to, I can't see how exciting. So it is 2x plus 48 equals 180, because you can take the measurement. Then minus 480 plus 180, oops, I didn't subtract. That wasn't right. Minus 48 gives you 2x equals 132, which then you'd find, you'd find 2x, and you divide by 2, which will give you x equals 1, hold on, that's not right. It would give you x equals 66. So, and then what you do is find the measure of EHF, which is up at the top. So, equals 2x, and then that'd be 2 times 66, which is what we solved, which then would give you x equals 132, or equals just equals 132, which means the measure of angle EHF is 132. Oops. Last example here. It's hard to teach geometry virtually because you kind of have to do it in person to understand. So once again, we're going to identify the supplementary angles. So in this case, it is WXC and CXY. Okay. And then write and solve write and solve to find x, which, as you can see here, is an x there, so we're just trying to solve and try and find x. So the sum of two measurements of complement angles, as we know, is 90 degrees. We're going to substitute the values, combine like terms, and then find x. So once again, let me zoom in because I need a lot. Of course, it's going to do that to me. Angle, WXZ plus CXY never cooperate equals 90. Then what we're going to do is plug it in. 4x plus 7 plus 35 equals 90. Then we will subtract, we combine like terms. These are terms together. 4x plus 42 equals 90 minus 42. Gives us 4x equals 48. Divided by 4, x equals 12. So now that we have x, we need now to find 4x plus 7. So we just plug it in. So 4 times 12 plus 7 times 12, 48 plus 7, which would give us 55. So the measure of angle ZXY is 55. Okay. So, there's a lot. If you need any help, message me on Canvas as always, and I'll be glad to help you. Oops, that's not what I wanted. If you need help, message me on Canvas, and have a great day.